Hello, everybody. Today we have properties of operations. So, expressions follow certain rules called properties. Anytime we use a property, it will result in an equivalent expression, or another way to say that would be anytime a property will result in a equal expression, meaning that both sides are equal to the same number. So, right here we have the additive and multiplicative identity. So when we're using variables, remember variables are a number we do not know, and variables can be assigned a number. So for example, p plus 0 equals p. Well, if p equals 12, the answer is still going to be 12, whatever p is. So for another example, p times 1 equals p. So if p equals 12, then 12 times 1 will equal 12. The number kept its identity. All right. And to show balance here, 12 times 1, if you remember your order of operations, all right, then we have the same exact way, right? 12 times 1 will equal 12. Okay? So that's where we get this 12 from. We multiplied 12 times 1 on this side, it equaled 12. And on this side, it stayed the same. It was still 12. So again, if I write a pink box or highlight it in pink, that means that's the answer I want you to write on Cami, so you do not have to write so much on that program. Okay, so when I'm thinking about additive and multiplicative identities, I think a lot about superheroes. So, for example, we have Spider-Man, who is Peter Parker. So, no matter what, Peter Parker is always his identity. All right? Or, for example, Batman, where Batman is always Bruce Wayne. That is his real identity. Okay, so think of it as their identity, meaning that it stays the same no matter what it's disguised in. So you can think of these as variables no matter what they are disguised in, no matter what superhero they are, right? Their identity will be the same. Moving down, we have the commutative property of addition and multiplication. So, for example, these are going to be variables. Again, these can be any numbers that we want, or sometimes they are assigned. So in this case, I've assigned p equals 12 and r equals 5 for both examples. So the example here on the left, p plus r equals r plus b. No matter what, both sides will equal the same number. And the same applies to multiplication. So an example I did down here for you, if p equals 12 and r equals 5, we have 12 times 5 is the same as saying 5 times 12. And I use these colors for a reason. So when we multiply or add, right, we can have 12 and 5. So I have red and blue. When we combine red and blue, it makes purple. And when we combine blue and red, it also makes purple. So it won't matter which order we combine them in. The end result will end up being the same. And the same can be said with my example of the superheroes for the commutative property. All right. So it does not matter what order we do it in, the identity will be the same. So for example, we could have Wolverine and Logan will still be Logan. His identity stays the same. And no matter what order I do that in, if I did it, for example, with Logan first and Wolverine second, he'd still be Logan. Okay? Or for example, we have Catwoman and Selina Kyle being her identity, right? But no matter if she's Selina Kyle first or Catwoman second, her identity will still stay the same. So I'm moving these around, but the answer still is the same. Okay? So I wanted to point out one thing, kind of irrelevant to the lesson possibly, but still kind of the same. So Superman, his identity is actually not Superman. His identity is actually Clark Kent. So he's a little unique because most people think of the secret identity, right, of Catwoman, for example. Okay. But for example, Superman's secret identity, he's always Superman, that's his real identity, but his secret identity is Clark Kent. He dresses up as Clark Kent as opposed to Selina Kyle, who dresses up as Catwoman. So Superman's kind of a unique comic book character in the fact that he changes his identity from Superman to go to his secret identity of Clark Kent, where, for example, Selina Kyle changes her identity to go to Catwoman. Next, we have the associative property of addition and multiplication, where we're going to use parentheses, which are grouping symbols. And on the other side, we're going to move these grouping symbols around different numbers to create a whole new expression, but both sides of the equation are still going to be equal. So again, I'm keeping 12 the same. So P equals 12 and R is going to equal 5, but I have a new variable here for S, and that's going to equal 3. So my first example, okay, I started off with my grouping symbols around 12 and 5, adding 3, and then I moved my grouping symbols to around the 5 and the 3, adding 12. So on this side, when I did my order of operations, I had 12 plus 5 equals 17, and then I add 3. On the other side, I had 5 plus 3 equaled 8, and then I'm adding 12. However, both sides end up being the same because 17 plus 3 equals 20, and 12 plus 8 will also equal 20. So it doesn't matter where we move our grouping symbols using this property called the associative property of addition and multiplication. Wherever we move the grouping symbols, our two sides will also equal the same. It's balanced. So another example using the same numbers that have been assigned to the variables. Well, P is going to be 12 times R, which is 5, multiplied by 3. And my grouping symbols are around 12 and 5. Now on the other side, I've changed my grouping symbols to group around 5 times 3. So I had 5 times 3 multiplied by 12. Well, 12 times 5 equals 60 times 3. On the other side, we have 5 times 3 equals 15 multiplied by 12. Well, 60 times 3 is 180, and 12 times 15 is 180. And I kind of think of this grouping symbol in terms of Star Wars, where no matter what, there is balance to the Force, okay? Which I'm going to show you a little video on. Next, we have the zero property, the zero product property, product being the answer to a multiplication problem. So whatever P is, whatever number this is that we've assigned to or that we don't know, multiplied by 0 will be 0. So for example, if I took apples and multiplied it by 0, well, I have nothing to multiply it by, right? I have no apples. So whatever the number is or whatever the object is, if it's multiplied by nothing, that means I have nothing. So your answer is going to end up being 0. So for this one, you're going to need to assign a number to the variable, say p equals 5, and you'll have 5 times 0 equals 0. Or for example, if I assigned 3 to the variable p, it's going to be 3 times 0 will equal 0. On the second page of today's worksheet, it's going to say, show the properties of operations and apply the following expressions. So we have the property, a problem, and then we have to apply the property. We have to use the property. So we have the commutative property of addition. So the problem they gave us was 18 plus Q. Well, according to that property, I can just flip it around and my answer will be the same. So here's an equivalent expression. For the zero property, or for the zero product property, we have C times 0. So no matter what number we have multiplied by 0, we're still going to get 0. For the multiplicative identity property, we have X times 1, where if I use the property, I'm going to be getting X no matter what. So the commutative property of multiplication, we have A times B, and when I flip that over, I have B times A. For the additive identity property, we have 9 plus 0 is still going to give me 19. Nothing changes. For these pink ones, you have to apply the problem and use the property to get your answer. And then for the associative property of addition, we have 5 plus 6 first in our grouping symbols plus 8. And when I use that property of associative property of addition, I'm going to take my grouping symbols and just move them around different numbers to give me an equivalent or equal expression. The bottom two you're going to do on your own. Now on the bottom, it says match the expressions in column 1 with an equivalent expression in column 2. So for this first one here, we have grouping symbols, and when I move them around, they're going to be around the B and the C as opposed to the A and the B. Then we have A times B times C, so I need to switch these around, and I have B times A times C. So these are two equivalent expressions. For my, it just equals A, right? So whatever A is times 1, the number is going to be staying the same. So, for example, 5 times 1, if A equals 5, is still going to be 1. Or if we have 5, another way to say 5 would be 5 times 1. And the last one, no matter which way I add up C, B, and A, it's going to be the same as B plus C plus A. So no matter what I add first, it's still going to come out the same. So, for example, I could say C is 1, B is 2, and A is 3. Well, if B is 2, well, let's see, C plus 1 plus 2 is 3, plus 3 is 6. So then I could do 2 plus 1 plus 3. Well, 2 plus 1 is 3, plus 3 is still going to be 6. So over here, you need to copy a very similar way to my first example, and this is what you're going to be doing on your worksheet, either on your packet or on Kami. To summarize today's lesson, I maybe would give a couple more examples of the properties above, or maybe just write a definition for the properties above. So you could always Google additive identity property and maybe write the definition right there and just copy it from Google. Okay, that is going to be it for today. Everybody have a great day and stay safe.